Hi, this is Will from .text. Today, we're going to be looking at an interesting example of taking raw, unstructured customer complaint data and transforming it into well-formatted JSON that captures the important information we need. This reflects sort of a real-world task where we would want to make an automatic customer service pipeline where we can take customer complaints and automatically dispatch them to the correct department with the correct information that department might need to look up that complaint or that order. We're going to be using an open LLM, Pydantic, and outlines to create the JSON, and we're going to do some very cool things that you can't even do with GPT's structure generation. We're going to take a look at that in a bit, but it's very interesting the things that we can do with these very powerful open source tools. So this is an example of the kind of problem that we have. Here we have a customer complaint. The user mentions their name, they talk about what they ordered, what's wrong with it, and then at the end they put an order number. And we need to transform that into JSON that has some of this important information all parsed out. First off, we have the first and last name of the user. We have an order number, and note here that the way the order number was specified by the user doesn't quite match this. We're imagining a scenario where we have an internal order number format that involves a certain letter, 2 digits, and then a dash and 4 more digits. It's a very common problem when handling real-world customer data because users don't often report things like telephone numbers, order number, invoice ID, bank account numbers in the same exact format that may be used internally. In this case, we can use the LLM and the structure generation to help sort of solve that. Also, we'll be asking the model to classify which department this belongs to for us, which is kind of a cool thing to do all at once. Let's break down the solution to this problem a little bit more detail. So we're going to be taking Pydantic. If you haven't used Pydantic before, it's a very cool library that allows us to use Python classes to really define exactly how our data should be typed, including details like regular expressions that may define certain fields. We can also make sure that certain classes are constricted to being a certain number of examples. We'll walk through a concrete case of this very soon, and you can sort of see how it works. We're going to use that with outlines to guarantee we get perfectly formatted JSON that has all the properties we would like. We're going to have the LLM handle almost all of this work for us in one pass, which is awesome. It's going to parse out the first and last name, it's going to properly format the order number, and it's going to classify the document for us, or the department that this belongs to. To do this, we're going to use outlines.generate.json to get the exact format that we want. Okay, let's start looking at the code and see how this all actually works. Here's our notebook. And we can see sort of we have the standard imports. We're going to be importing JSON because we're going to read JSON files so we can actually see what our complaints are. We're of course going to be using outlines. That's going to be the main sort of workhorse of this notebook. We're importing torch, but only so that we have access to its B float, which you see right here, because we want to specify the sort of torch type so that we aren't using too much memory. And then we're going to be using transformers auto tokenizer. I've used this in other videos. I really like it because it allows us to take an instruct template and automatically apply it in the right format for the model we're using. If you haven't used open models a lot, one thing you'll find is the instruct models or chat models often have a very specific interface, and you need to make sure you follow the format for that. Auto tokenizer takes care of all that for us, so we don't have to worry about it. And of course, we're going to use text wrapped and we're going to use dedent just so that we can have multi-line prompts and not have to worry about having weird white space cause a problem for us. Here we are actually creating our model, instantiating our model using outlines. I find this to be a very easy interface. I've mentioned this before, but I actually use outlines almost all the time when I'm working on LLMs, even if I'm not using structure generation, because it makes it very easy to load and use them however I want. We're going to be using the transformers library for this, but we also support Llama CPP. As you can see, it's pretty straightforward. We just pass in the model name, some configuration details we care about. I'm on a Mac, so I'm using MPS as my device type. If you're using a Linux machine or Windows machine and a GPU, you probably want that set to CUDA, but you get the idea. All of this is pretty compact, and I find it very easy to work with. We're also going to very quickly load the tokenizer from Hugging Face's tokenizer library. Again, this is there only so that we can use the apply chat template method to help us make easier instruct prompts. Let's start off by looking at actually how we're going to define the structure of our data, and we're going to use this using Pydantic. Pydantic is really great if you haven't used it before, especially for defining these sort of complicated data types that we actually might need for things. So in this case, we have a department, which is just a sort of standard Python enum. It can only have 4 possible values. We're going to have clothing, electronics, kitchen, and automotive. And again, this is going to be where the model is going to classify which department this complaint belongs to. Then we're going to define the complaint data itself, which will make use of this enum. We'll see that in a second. Our first and last name are just strings in Python, so that's not a problem at all. They're pretty easy to specify. Our order number is a string, but we do want it to match a specific pattern. This is a very cool thing, and I want to point out you cannot do this with OpenAI structured generation. OpenAI will allow you to sort of specify a format of the fields in your JSON object, but you do not have granular control over what's in those fields. In this case, we can very clearly specify exactly the structure of the order number, which is the letter A, D, or Z, followed by exactly 2 digits, a dash, and then 4 more digits. We're imagining this is sort of the standard structure of our internal order numbers. And again, users don't always report order numbers exactly as we want them, so this saves us having to clean that data up. Finally, we're going to have it automatically classify the department, and we don't actually have to do anything more. We just apply the enum we already defined here, and it will handle that for us. Again, this is a restriction you would have to ask OpenAI to do. You'd have to beg it to please, please, please pick one of my favorite departments. But in this case, we don't have to worry about asking or begging. We will get them all to do exactly as we want when we do this. And this, I think, is my favorite part right here. When we put this all together, this is our complaint processor. We're using outlines.generate.json, passing in the model we defined above, and then passing in this complaint data class, which tells it everything it needs to know about the structure of our JSON. And this is where I think LLMs are really cool. This is our whole complaint processor. If you've worked in data science before, or data engineering, or any programming job involving cleaning up of unstructured data, you've probably seen tasks like this that involve several passes where you would probably need to try a bunch of weird regexes to parse out what the order number was, try some simple rules to figure out the first and last name, and then for departments, probably build like an entirely separate model to do classification. LLMs are cool because we can have it do all this at once, and one surprising thing we'll see in a moment, the performance is actually really great. And remember, this is an open model running on my machine. We're using Phi 3, the medium, which is one of my favorite models. Very great performance for its size, really fun to see. And again, it's cool this can all run on a consumer desktop. Here's your prompt we're going to create. One advice I would give when you're using structured generation is create the prompt as if it's an unstructured problem. Yes, structured generation will guarantee that you get the results you asked for, but we want the model to succeed. So it helps if we describe the structure we want as the output and give, sort of all the information we would want to give in unstructured model to help us answer the question. So in this case, we describe exactly the format that we want, and then we go ahead and pass in the complaint so that the model knows what to process. And of course, we're using, again, as I mentioned, apply chat template because this helps solve the problem of how exactly this needs to be formatted. It's very easy now, and we kind of have that solved. So I have this actually here twice. I don't know why, but this is just sort of, we're instantiating our complaint processor again here. Just to remind you, it's very, very simple to do this in Outlines. I think one of the best parts about Outlines is you spend almost all your time thinking about the structure of your problem, which is a good thing to think about, and almost none of your code is actually worrying about how to implement that. It's usually just a one-liner, which is almost no more work than required to generate unstructured text. And now we're actually ready to run. We're just going to go through all of our complaints. We're going to create a prompt for each complaint. We're going to parse the result, and we're going to append the results to results. Sort of straightforward. We could have done this in a list comprehension if we wanted. And we can see here is a complaint we have, and we can see how it gets processed at the end, and it all works, right? And we see that this is a complaint about a shirt, and the model did correctly label it as a clothing complaint. And again, it's doing this all in one pass, which I think is really awesome. Okay, so here's our final sort of assessment of how well this did, and I think it did pretty awesome. It got 100% of the departments correct, which if you watched our earlier video on zero-shot classification is actually better than our zero-shot classifier, which was trained specifically to solve this one task. In this case, trying to do multiple tasks at once actually leads to superior performance in this task. Likewise, when we look at our order numbers, we only got one wrong. So 98% accuracy on order number is really good. Overall, our model did excellent, and I think this is just a wonderful example of how you can use structured generation and local LLMs to automate tasks that frankly are tedious and boring and would have taken a lot more time and code to do without an LLM. If you found this useful, please hit like and subscribe so you can keep up to date with all the new videos that we'll be producing. Thank you so much for watching, and I hope to be able to share more exciting ways you can use structured generation in your day-to-day life working with LLMs to get fantastic results and build some really cool stuff.